Hi guys, this is I think our 11th learning series session, and I am very happy to see the turnout in this. So, you will all see that you are muted. So if you want to ask any questions, there is a Q&A option in the Zoom setting where you can ask any questions. If and there's also a chat setting, so we can ask over there. Otherwise, if you want to speak, so you can just raise your hand, and I will give you the control to unmute yourself, and uh then you can ask a Khurram. So this time we have Khurram Wali Khan, and then I'm just now over to you, Khurram, so we can begin. Yeah.
All right. So is my screen visible to everyone?
Yes, it is.
Okay. So, greeting everyone. As you know, my name is Khurram Ali Khan, and I'm excited to be here and share insights on API performance testing today. With over a decade experience in software testing, so I've been part of numerous projects focusing mainly on ensuring reliability and scalability of APIs. So when we talk about API performance, we'll basically delve into the intricacies of API performance testing, how API plays a crucial role in modern software development, and it's imperative to ensure they perform optimally under various conditions. So basically, we will try to understand the key metrics we can evaluate and explore one of the tools that help us identify gaps in API performance. So let's buckle up for an exciting ride into the world of API performance testing. Uh, so let's first start by talking about APIs. So how APIs are to me are like invisible heroes of the modern web. They basically power everything from social media interactions and online shopping experiences to weather updates on your phone, or travel booking confirmation via email. An API acts as a middleman, allowing different applications to talk to each other and exchange information, just like you can see in the slide. Just like a waiter in a restaurant takes your order and and delivers the basically food that you would call your order as a request, and the food that gets delivered at a response from the kitchen, that is the backend system. So APIs basically enable us to smooth communication and data flow between various software components. Similarly, we can imagine a travel booking website where the API interacts with the airline database, hotel reservation system, and payment gateways to retrieve information, process bookings, and deliver a seamless user experience. So let's go to next slide. Now, this is one of the most important topic because it lays a foundation that why do we need API performance testing in the first place. So just like waiting for a slow waiter can basically ruin our dining experience. Similarly, the slow APIs can frustrate users and damage our reputation. So performance testing is crucial in that context for identifying any weakness in our APIs before they impact our users. So it's like taking our car to a racetrack before a competition. So you want to ensure it can handle the pressure, navigate obstacles. By obstacle, I mean high user load, slow response time, scalability issues, and so on and so forth, and deliver top performance. Imagine we can also imagine a banking application. If the API responsible for processing transaction performs poorly during peak hours, user might experience delays or even failed transaction. So this can lead to frustration, loss of trust, potential customers switching to competitors. So in that context, performance testing basically helps prevent such scenarios by ensuring that the API handle high volume of transaction efficiently and reliably. So let's look into, let's talk about some of the examples that are relevant to this particular, for to various industries or sectors. Like for example, we can think of e-commerce platform. So e-commerce platform, if I experienced a prolonged like downtime during a peak shopping session season due to slow API response time. So as a result, any merchant would suffer, and customer won't be able to complete transactions. They won't be able to search the product that they are looking for, leading to direct loss of sales revenue and damage to the platform reputation. Similarly, in case of banking system, if there is an outage, so a major banking institution basically suffered an API outage back in 2018-19. So that basically prevented the customer from accessing their accounts, transferring funds, or making transactions. So that kind of a disruption led to financial losses for customers, missed payment deadlines, and regulatory penalties for the bank. We can also think about like travel booking service Expedia. So a travel booking service experienced slow response time during a holiday season rush. As a result, customer basically faced delays in booking flights and accommodation, causing deep frustration and leading to booking cancellations, loss of revenue, and damage to customer loyalty. So as I've given an example of Expedia facing low API response, during the holiday booking seasons. In case of social media platform, we can think of like popular social media platform like Facebook or Twitter. So they often encounter, API performance issue. Back in 2020-21, Facebook did suffer due to that. So which basically resulted in delayed, post updates, comments, and and user interactions getting suffered due to that. So user basically experienced disruption in their social engagement, leading to this, decreased user satisfaction, loss of user engagement metrics, and potential data loss of advertiser as well. Similarly, in case of a healthcare system, as we know, at a time of COVID, healthcare system went through a terrible time in terms of severe complaint. You have many users looking for medical care, instant medical care. So healthcare system API basically its infrastructure failed in one of the instances for UK NHS, National Health Service. So it failed to handle increased traffic during a public health emergency, causing delays in accessing patient records, scheduling appointments, processing prescriptions. So this basically led to compromised patient care, increased administrative burden, and potential legal liabilities for healthcare providers. So back in 2020-21, when the COVID, the pandemic was there, and so in that era, that there were like multiple instances of that kind of a mishap. Similarly, in case of when we talk about internet, common the feature like streaming services, right? Like Netflix or any other. So a streaming service experienced a buffering and playback issue due to API performance degradation. Subscriber encountered interruption in their viewing experience, resulting in decreased subscriber retention and negative reviews. So so a loss of subscription revenue happened greatly due to that. Same for gaming. If anyone, if you interested and might have played online gaming on a platform like Xbox Live. So on one of the instances, due to the API latency during peak gaming hours, players experience lags, disconnections, inconsistent gameplay, leading to frustration. Decreased player satisfaction means a loss of in-game purchase revenue. So that some of the we can say relevant examples of different industries and sectors that basically suffered due to poor API performance in specific scenarios. Now let's talk about what do we mean by performance. What are the key areas that we are looking for? Obviously, so performance testing is basically we can say like a doctor's checkup for your API. We assess various aspects of its health, to ensure it can perform, optimally in the real world condition. Response time is like, checking your heartbeat. How quickly does the API respond to a user request? So ideally, this should be as low as possible, like in milliseconds, for a seamless and responsive user experience. But throughout, is throughput, as it the second point is specific to, is like measuring your lung capacity. So how many concurrent user requests can the API handle efficiently, right? Similarly, scalability, we can draw a concept like seamlessly. Scalability is like testing your muscles. Can the API adapt to increased workloads, such as search in traffic during a promotional event or a holiday season rush? And finally, scalability is like checking your overall health. Can the API stay strong, reliable under pressure, avoiding outages or errors that could, disrupt user experience? Now, what do we do? Like, what is meant by performance testing process? So, just like well-oiled machine, it consists of several distinct phases, basically, that work together to ensure a successful and informative testing experience. So, the planning phase is like laying the foundation for your performance testing journey. Here we basically are, meticulously looking to gather all the essential information to build a solid testing strategy. We, delve into the requirements. What are the expected performance goals for, our APIs? How much user load do we anticipate uh, based on our scenario that we talked a little while back, based on different industries and sectors? What are the acceptable response time to ensure a smooth user experience? Next, we can basically configure a testing environment that closely resembles our production environment. This ensures the test results are, as realistic as they can be. Uh, we then move on to selecting the right tools for the job. Just like choosing the right tool for construction, hammer, nails for building, bulldozer for demolition. We need to pick the most suitable, load testing tools based on our specific needs and the budget. Finally, we define, the key performance metrics we will be measuring during testing. These metrics basically act as our compass, right? So guiding us towards identifying bottlenecks, evaluate overall API performance. Once we have the foundation in place, it's basically then it's time to craft a blueprint for our performance test. That then this comes with test design. So test design basically would involve identifying realistic user scenarios. Imagine user APIs, user browsing products, adding item to the cart, and checkout. So we translate these scenarios into concrete test steps that a test script will record and execute. So for each particular scenario, we establish expected results. So what is the ideal response time for users? Adding item to their cart, how much load can the API handle before experiencing performance degradation? With these expectations documented and defined, we develop our scripts. These scripts basically are like tireless virtual users bombarding our APIs with simulated requests based on the user scenarios and workloads we define. So this is where you can say this is where the rubber meets the road. So in the text execution phase, we basically we would put our crafted plans into actions. We hit the start test button, unleash our automated test scripts. These virtual users would bombard the API with simulated requests, mimicking real world user scenarios and workload as we would have designed in our test. As the tests run, we closely monitor key performance metrics, right, in real time. Not only on the client side, but also on the server side as well, using logs and many other mechanisms that we will talk a little while after. So just like a pilot monitoring instrument during a flight, we keep a watchful eye on the response times, throughput, resource utilization, like how much memory being consumed, how much CPU, cores are being consumed, how much bandwidth is being consumed, so on and so forth. So we keep a watchful eye on response time, throughput, utilization. So this real-time monitoring basically allows us to identify any immediate issue or bottleneck that might arise during the test execution. Finally, we basically gather all the performance data generated through the test. Now let's look into the tools of the trade for the API testing arsenal. We have. Let me just. Are you able to see this? Okay. Sorry about that. Okay. So let's talk about the API testing arsenal. So let's say we have a whole set of arsenal of tools at our disposal for API performance testing. So just like a well-equipped mechanic has a variety of tools to diagnose and fix car problems. So similarly for load testing, tools are like stress testers, which would test the health of our API, simulating high user load, helping us identify bottlenecks. Example of that we can think of let's say we are testing an e-commerce API. We can use a load testing tools like JMeter to simulate hundreds of concurrent users adding items to their cart during a flash sale season like Black Friday. So this helps us basically identify bottlenecks in the API that might cause slow response time or even crashes under high load. Then monitoring tools are basically, you can say, like our blood pressure monitors, keeping track of key performance metrics in real time. So we can catch any anomalies before they become major issues, right? So example of that, we can say, if you guys have heard or aware of tools like Prometheus, which is very popular in monitoring tool that can basically be integrated with our APIs to track key performance metric like response time, throughput, and any error rates that may be happening during the execution of our test. So imagine basically Prometheus as a real-time dashboard that continuously monitor the health of our API layer, just like a blood pressure monitor keep track of your vitals. And finally, the performance analysis tool are like detectives. So we can say helping us to analyze test results, identify weaknesses, and pinpoint areas of improvement to optimize the API performance. Right. Now, to see performance testing in action, as we looked and talked about in the earlier slide, performance testing is not just about identifying problems. It's basically about proactively planning and ensuring our APIs are prepared for real world scenarios. So imagine we are launching a new e-commerce platform and our API which are responsible for processing all the, let's say, holiday season orders. So performance testing basically will help us to ensure that we are prepared for the critical time. So we can basically simulate high traffic volume similar to the one that we can see in the graph. That part of that you would be able to see. So performance testing help us to prepare for the critical time and identify bottlenecks. So this allow us to basically optimize the APIs to handle the expected user load and maintain a very positive user experience even during peak shopping seasons. So another example is mobile banking application. It's very common now. Performance testing is crucial for ensuring that API responsible for account balance inquiries, one of the most basic query. So money transfer or bill payments and so on and so forth can, they all function smoothly under heavy, user load. So this basically help prevent delays, errors, frustration between customers who might switch to a competitor with a more reliable banking experience. So just be proactive in testing, optimizing APIs, identifying issues, so we can then build trust with our users and gain a certain competitive edge in the market. So that's the presentation. Now let's look into some of the areas that the tool that I would like to share with you guys and how we can configure. API related performances. So I have just, can you guys share, see my screen of that I've just
Yes.
shared? Yeah, okay. So this is a JMeter tool. As you can see, the test, how it is configured. So we have a, prepared a, collection and added basically, assertions. And as you can see, these are like APIs, and we have added assertions for response code, for response message, for response header, for size assertion, and then duration. Like if there is an SLA of we expect our API response time to be less than a second, then we should basically consider the response duration related assertion as well. So all these basically kind of a fundamental assertions just to showcase like what kind of indicators that we are looking for while designing our basic API test. So we have like as you can see, like 5 APIs here: single user, list of user, create user, update user, and delete user. So similarly for all rest of the APIs, the tests are configured the same way with the same kind of assertions. And for creating a condition that we have created to showcase like what kind of virtual user load that we would like to test it with. I've set it in value as virtual user load as 500. We usually set it when we are really testing, going for load test. We usually set it in like 2,000 or 5,000 or 10,000 or 25,000 like that. Then the ramp up period is there, like in how much time we expect our load to be increased to a maximum thread level, and loop count. If we want to carry on, in scenarios like endurance test, right? We would like to our test to continue for let's say a day and see like how many errors are likely to occur. So in scenarios where we expect that user load would be coming in a spike, and then it will be carrying on for let's say 6, 8, 10 hours in scenarios, especially in scenarios of emergency in case of healthcare, or in scenarios of any flash sale on a season where a user load is expected to be consistent over a period of time. So we can mention a loop count and give even mention infinite, create an infinite domain, let our test go and see at what point our API start giving a huge number of errors, and start showing issues that are significant and identifiable to note down and list all the potential bottlenecks in our API layer. So that's about it. So when all is everything is set, we can basically view results here as well. For the essence of time, I have basically generated reports with different conditions, which I am going to just show you guys here. Please let me know if you can see the browser where different reports are open.
Yeah, we can
Okay.
see it. Yeah.
Okay. So before we, deep dive into this report, let me explain different kind of performance testing that we can perform and get a very thorough, robust kind of a report. So, for example, if we are to perform a load testing, then we can simulate 1,000 concurrent user accessing an e-commerce API to measure response time during peak hours. In case of stress testing, we can ramp up the number of concurrent requests to an authentication API until it reaches the maximum capacity, so causing response time to degrade or errors to occur. So similarly for endurance testing, I talked about, so we can sustain a constant load of 5,000 or 10,000 concurrent user accessing let's say a streaming service API for up to 24 hours to monitor memory usage and system stability and other indicators over a period of time. In case of a spike testing that we just talked about, like in case of a flash sale on a season, many users would be inclined to land on the site and able to sort and search and add right into the cart and be able to check out. So in a scenario, we can send like 10,000 requests or even more, like 25, 50,000 requests to, let's say, a ticket booking API with a short time frame to evaluate how the system handles certain spikes in user activity during a flash sale event. Concurrency, we can say, is like simulating users, concurrent users, updating their profiles on a social media platform concurrently, and observe how API handles concurrent write operations without, data corruption or conflicts. So that's a very basic or a relevant scenario in that sense. Volume testing, we can say we can upload like up to 1 million records to a database through a bulk data, import API endpoint, and measure the time it takes to process and store the data. Similarly, if we think of scalability, so scalability would involve like gradually increasing the number of servers hosting a messaging API, and observe how the system scales to handle increased message traffic without degrading in performance. Breakpoint testing that I mentioned about a little bit, like determining like the maximum number of concurrent connections, and let's say an IoT device management API can handle before it starts dropping requests or experiencing timeouts. So in IoT realm, it's a very valid scenario that once the requests get stacked up, the number of failed request or a dropped request increase significantly. In failover testing, we can simulate a server failure during peak usage hours and verify that the API failover to a backup server seamlessly, maintaining service availability and data integrity. So similarly, the latency related testing, we can say it's basically measure the round trip time of API requests from different geographical locations, and assess how network latency impacts overall response time. So someone sitting and accessing e-commerce website from the same region, like North American region, someone is sitting in New Zealand, someone is sitting in Brazil, someone is sitting in Singapore, so on and so forth. Benchmark testing compare the response time basically and throughput of a payment processing API against industry benchmarks to identify areas for optimization and improvement. Now let's talk about and have a little bit deep dive and talk about the report. So as you can see, the dashboard basically first starts with the app decks. As you can see, the graph basically highlights that there is a high percentage of API which pass, but some basically failed as well. So let's look into each and every section and try to understand what and how these values and these metrics and these calculations are made. So we are able to understand each and everything in detail. So let's starting with AppDex. So AppDex is basically it's meant for satisfied and the tolerating count, as we can see. Satisfied count is obviously a number of requests for which response time is lower than toleration threshold that we would have set in our test. Then the tolerating count is the number of requests for which response time is higher than the toleration threshold, but lower than the frustration threshold. So the formula is basically like you can say satisfied count plus tolerating count divided by 2 divided by total number of samples, right? So satisfied count we have already discussed about like number of samples with the value less than the toleration threshold which is defined, and we can see here. So tolerating count, a number of sample with value more than tolerating threshold and less than frustration threshold. So there is a formula to it, and all the values are calculated accordingly. Similarly, if we go into like statistics, we can see like how many executions were made. Like it says 15,000. How many were failed? 106 were failed. What is the percentage error? What is the average? What is the minimum? Like how much average time it takes for the execution? What is the minimum time? What is the max time, which is obviously a failure? What is the median? What is the 90th percentile, 95th percentile, 99th percentile? So there are many relevant details if we look into, who do, have a real a deep dive, try to understand, and then be able to infer the kind of information, get the kind of right information that we are looking for. So like T is basically timestamp, sorry, TS is timestamp, T is elapsed time. A number of samples is given, max value is given, T is there, minimum TS is there, throughput is there. How throughput is calculated is also, the calculated value throughput is quite basically simple from the value of the, label that is given here, and from the basically time that we able to put in the formula and get that value. So response time over time, let's look at the charts. Yeah. So response time over time basically shows a graph of average response time in milliseconds for each, sampler during a test run, right? Then we have next is response time percentile over time. So there is also, response time over percentile over time, which basically displays the time it takes to process, a successful request over the course of your test for different percentiles. So this graph is a great tool to, use if you understand and use it to determine how long a user will be waiting for a page to load on your site, right? So the active thread over time, let's look into that. Yep. So showing how many active threads are there in each thread group during, test run. Then next is bytes throughput over time, which says the graph, this basically displays the number of bytes sent and received during the, execution of a load test using JMeter. Then next is latency. Latency is over time, right? So we talked about latency, right? So this graph basically display the response latencies during the load test. Latency is kind of a duration between the end of the request and the beginning of the server response. So that's the latency we are talking about. So in terms of testing latency for different geographical vicinity, this become one of the most primary indicator of seeing like what kind of user experience would user expected to get based on the kind of latency that that application is facing based on different loads from different geographical locations. Then we have so yeah. Then we have connect time over time. So this graph basically display the average time to establish connection. What does it mean by connect time? Connect time is basically it's taken to establish a TCP connection between a client and server using TCP handshake. So if a TCP handshake is successful, then the client can send further request. It means HTTP request through HTTP layer. If not, the client can't, talk to the server. This can happen if the server is not live or busy responding to other requests. So again, a very important, indicator, giving us a deep insight into the health of our API layer. Now let's look into, throughput, starting. Starting with hits per second. So hits per second is basically, when there is a load with which the server is being hit, it means we can say n number of hits are sent to the server every second, whatever value which you have configured in the test. Or hits per second is the total load on the system or application, right? Then next is codes per second. Right. So the codes per second, this graph basically, represents the rate of response codes over a time, or the graph displays, response code per second returned during the test. Then there is transaction per second. Yes. So transaction per second basically is the number of transaction per second for each, sampler. It counts for each second the number of finished transactions, right? Then there is total transaction per second. Yeah, so total transaction per second, as we can see, it highlights the total number of transactions that are executed per second. Then there is response time versus request. Yeah, so as we can see, the response time, the graph represents the median and the average response. The basically depending upon the time on the number of concurrent user API request, and the response time is, so the response time is calculated at sample time or a load time or a elapsed time is the difference between time we request, when the request was sent, and the time when response has been fully received, right? Then we have last but not least, yeah, latency versus request. So this graph basically represent the median and the average latency time depending on the number of concurrent requests. So latency is, as we already talked about, is a difference between time when a request was sent and time when a response has started to started to be received, right? And let's talk, let's go to and explore response time, time percentile. So as we can see, so this graph basically will display the percentile for the response time values. So at x-axis basically represent percentage, y-axis represent the response time value. So this graph basically shows response time of each percentile increase every 10% as you can see in the graph below. So similarly, response time over time. Yep. Response time overview. Basically, response time overview is basically, you can say this graph shows the entire overview for the time it basically took your system or machine to process all your requests, right? So you can use this graph along with response time percentile over time graph to compare against your expected result in order to determine that the time a user will spend on your site, or to identify any particular bottlenecks. Then there is time versus thread. Yep. So this graph basically shows the response time changes with the amount of parallel threads. Like naturally, the server takes longer to respond when there are lots of user requests. It simultaneously, or the change of the response time through simultaneous thread as a rule, the more active, simultaneous threads are, the longer it takes to serve or to respond. Then the last is response time distribution, right? So this graph basically displays the response time for each sample in a bar chart form. So the response time are grouped by their durations. Each group is kind of an you can say an interval. For example, from 0 to 1 millisecond, or 0 to t millisecond, or from t to t millisecond to 2t millisecond, where t is configurable. For each group, the distribution of you can say the samples, the number of samples for each particular sampler is displayed in a bar chart. So the graph shows the proportion between sample according to the response time. So that's the basic of one of the report. We can look into report of other reports as well, where I said different kind of conditions. So this report basically kind of showcased that in case of spikes, where we saw in this particular report, where there was a gradual increase, with a certain number of ramp up, we have a gradual, we set a value to have a gradual increase in the user load. API for the API request. But in this particular scenario, we basically send a huge number of requests in a very small ramp up time. Reason is that we want to test in case of a spike, right? How the system would go. So as we can see, the failure rate, as we can see and compare between this performance load test for our API and this one, is significantly increased. There are many errors to it. We can see all the details to the errors, and get the error details as well, like how many errors are there, and what kind of API request assertion that we set getting failed. So the operation lasted too long. It took 1.51 millisecond, but should not have lasted longer than 1000 milliseconds. So we set our SLA that API should have responded, that I've shown you in the JMeter, right? So I've showed you here. Here, yep. So we set the duration in millisecond to be 1000. So in case there is a breach of SLA, we would get a report that there are total number of like 8 errors, and the reason given as well, that this particular assertion that we said, it has failed. So we get a very detailed micro level kind of a breakdown, and as well as the data in the CSV file, and we can look into have a very deep insight into our APIs, and be able to identify lots of areas that we can basically segmentize and understand in their own isolation and integration with other things that are working in together. So I
Khurram,
hope
yeah, sorry for cutting you. I was just saying, can we take a questions break as well? Like if anyone has any questions.
yes.
Yeah.
Yeah, I was just about to say that I hope everyone liked this nice overview and the context of API performance testing. And if anyone has any question, please do feel free to ask.
Yeah, you can raise your hand or you can write in the QA or in the chat section.
Yep.
If you raise your hand, we will give you permission to unmute. I don't think there's anything in the Q&A and chat so far.
So either everyone understand everything.
Yeah, okay, so we have. Can you further elaborate the ramp up time?
Yeah, sure. So
Okay, Osama has also raised his hand. Osama, we'll just get to you after answering this question.
yep. So yeah, so ramp up period is basically uh, telling our performance test to simulate a virtual user load in a certain number of time, right? In certain number of seconds. So let's say as we talked about different kind of testing scenarios, right? We talked about endurance, we talked about spike, we talked about load, and so on and so forth, right? So in that context, we want to set conditions. We want to set values as such that we are getting the we are able to simulate a number of transactions by virtue of our time value that we have passed in terms of ramp up. So if you want to achieve to the number of threads to be executed in a let's say 100 second time period, then it will get gradually increase. You will get a very static kind of a line in a chart, and the execution will be very moderate. But in case of a spike, so if we let's say if we set value like 1000 virtual user, and if we set a spike 2 second or even 1 second, then in that scenario the ramp up time, it means that after 1 second the maximum number of virtual user or threads that we call it would be executing, and response request will be generated to have a response within the due time that we have set conditions for. So that's how ramp up works.
Okay, so I'm just going to ask Osama, you can unmute. Yeah, we've given you
Hi.
permission.
Hi, Khurram. Yeah, it's a really very informative lecture, and actually, I want to dive a little bit deeper. I want to ask about the event-driven architecture, and also, actually, I have used JMX file in some architecture using REST microservices and in some event-driven architecture. But I was not pretty much sure about, because I did not get chance to work something in professionally. Whenever if you are not able to work professionally, you are not get the domain knowledge, etc. So this is what I want to ask. Can we create event-driven? How can we create event-driven architecture by using this load testing.jmx file? Maybe because I don't think so. The JMeter is good JMeter is good for uh, writing framework for reusable coding and maintainable architect kind of things. So we can create bit services, and we can create a bit functionalities, load testing functionalities, and use those JMX files in some event-driven architecture and use REST microservices to call them. Is that possible in some way? Or you have worked in the professionally like that?
Yeah. So Osama, to your question, I haven't worked in any scenario where the event-driven architecture is taking the JMX file for executing them and getting the results on the fly based on the need of the application. However, what scenario that you have described in particular, so there are multiple other tools or frameworks that are available, like the tools like K6, Gatling, and other tools which basically provide you that kind of leverage which you can utilize to create a event-driven application and set up your test based on the need of your application to be executed in as part of the cycle, and then be able to get a desired result in a kind of a dashboard. So there are multiple tools available. Some are paid, some are not so, but they do provide that kind of a leverage that you mentioned.
Yes, I knew about it. We can even create a Cucumber framework by using this JMX file. But I'm actually thanks for elaborating. Actually, but I'm actually want to get
Mm.
something more about event-driven architecture. So if we are really working in the in this professionally, so we have some project uh, for performance testing.
Mhm.
I can I want to see the framework which we are using for the performance testing. This is what I want to ask.
Yeah, sure. That is something we basically can look into and discuss further about. There are multiple need-driven requirements. Some depend obviously on the project's need. So some are related to that you need to create a, as you mentioned, cucumber-driven framework. Some are required you to create a framework as such that you have many APIs in rest assured, or let's say you have in Postman, and you want to basically take all those APIs, export them, and make sure that your performance tests are created and executed in a way and become part of a CI/CD that through which you can basically continuously able to monitor the results on the
Yes,
fly. So yes,
yes,
so that
yeah,
is definitely something. There are based on, as I mentioned, based on your particular needs, there are many approaches to it. You can have your framework styled or created in a way that would accommodate this particular need that you have mentioned, and the other scenarios as well, as per the requirement and the situation pertaining to the needs of the project. So yeah, definitely that is something to explore as much as possible. But I have just elaborated as kind of a window, like kind of a basic insight into how to get into like how to think about why is it important first of all to think about APIs performance testing, right? And
yes.
why and what kind of relevance there is in terms of business and different industries and sectors. So this is kind of a window insight, an initial overview of how we can utilize one of the tool that is available and create our scenarios and set our conditions, set our assertions, and get the result in terms of report that we just had an overview of. So yeah, so there could be many, many other approaches, tools, frameworks, methods that we can employ and use. as per the, as per our needs.
All right.
So as I mentioned, So as I mentioned about endurance testing, as you know, that we want to simulate a user accessing a streaming service. So when we talked about streaming service, this remind me of a project that I worked on. So it had WebRTC, based server, which is specialized for media, streaming, or voice and video. So we had a similar kind of a scenario. We had to basically design our performance or load test in a way that would incorporate all the intricacies related to the WebRTC server and the protocols, and we were able to execute and identify lots of issues in that. Similarly, for virtual event management platform that I work for, similar kind of scenario that user would come in. So certain number of companies would like to showcase their products or talk about their marketing strategy over a virtual event platform, where hundreds or thousands of users would just come in at in a particular time. They would have a voice and presentation slides, able to share slides, and able to have a voice and video interactive session with a speaker. There is a moderator and everything is there. So in short, based on our project needs, we can devise a plan, as we talked about earlier, like how important it is to understand and plan our execution and test according to the needs of our business or the project or the set of tasks that we would like to optimize and look for the gaps in terms of performance.
Okay. Khurram, we have a few more questions as well.
Yes, please. Yes.
How to calculate the ramp-up period time?
Yeah, it's basically you just pass the value. It's already mentioned here. It's in seconds, right? So if you want to, let's say, if you want to conduct endurance test, so it depends on the need, right? If you want to conduct the endurance test, so you would, let's say, mention as you can see, number of the thread count is 1,000. We can basically, let's say, want to monitor the health of all our APIs, which are with all their assertions here listed here. We can, let's say, mention ramp up time, let's say 10. And in case of endurance test, since we would like our test to keep on going like for an extended length of time, we can set a loop, and then we can run the test. It would likely easily go for hours and hours, and give us an insight that with so many active number of threads, the performance of our API is let's say so forth. If there are many issues, if there are many errors happening that we are able to identify early on, we can set these conditions as well. So we can stop the test if if the sampler has error. So or we can just stop the test in any specific amount of time. So there are the ramp up time, coming back to that. So there are this is the value would be condition driven. So what kind of testing we are looking to perform. So if it's an endurance test, I've given you example for that. If it's a general load test, I would give a ramp up time, let's say 100 second or even more than that. So as we would like to just simulate a consistent concurrent user accessing let's say our e-commerce API to measure response time during peak hours.
Okay,
Yes.
next one is difference between throughput and scalability.
Yeah. As we talked about, the throughput, throughput. And what do you mean by scalability? Can whoever asks can elaborate a little bit more?
Yeah, it was Mubin. So if you want
Yeah,
to
if you can just.
speak or if you want to type, you can just raise your hand. I can go to the next one if you want during that.
Sure.
Does the number of threads users depends on your testing hardware to precisely simulate traffic? What will
Yes.
happen
Yes.
if we have an unpowered machine? Will we be able to simulate 5,000 or 10,000 users traffic?
For an unpowered machine?
Yeah, if we have an unpowered machine.
So, like, if there is a power, there is no power. The power machine is unpowered. So, Like, I don't understand the question in particular. Like, why would you want to execute a 5,000 user load on an unpowered machine?
Okay, so the people who've asked, maybe if you guys
Yep.
want to elaborate
Yep.
further.
Elaborate. Yep.
Any more questions? Yeah, Mubin, yeah, I'll just give you the option to unmute. You just have to raise your hand if you want to talk. I have given you the option to unmute. Yeah.
Okay.
Yeah, you can.
Okay.
Yeah.
Okay. So
Yes.
basically, I want to understand, Wali, the difference between Khurram, about the difference between throughput and you initially at the start of the presentation you mentioned three things, right? Response time, second was throughput, and third one was, I believe, this thing scalability. That's what
Hmm.
I
Yeah,
understand.
yeah, yeah,
So
yeah, yeah, yeah. I
I
remember.
want to understand
Yes.
between the
Yes.
throughput and the stability in that from that perspective.
Yeah, sure. If you would like me to just, repeat what I talked about, those 3, 4 points, I
Yeah,
can do
yeah,
that.
yeah,
Or if you would, okay.
yeah.
All right.
Sure.
So thank you, Mubin. So response time, you can say, is basically, you can say, is like, checking the heartbeat. So how quickly does the API response to a user request? So that's a response time. So ideally, this should be as low as possible, right? So think in milliseconds for, 300 millisecond, 200 millisecond, 100 millisecond for a, seamless and responsive experience. Throughput is like measuring your lung capacity, right? So how many concurrent user requests can our APIs handle efficiently? While scalability is like testing your muscles. Can our API adapt to increased workload, such as surge in traffic, right? During a promotional event or holiday season rush, things like that, scenarios like that. And finally, I believe, was stability. So stability is like checking our overall health. Like, so can the API stay strong and reliable under pressure, avoiding outages or errors that could disrupt or cause our user experience to be rendered as poor.
Okay. So the other question, the unpowered machine, it was actually underpowered.
Okay,
What
okay,
will
okay, okay.
happen if
Yeah,
we have an
okay.
underpowered machine? Will you be able to simulate 5,000 or 10,000 users traffic?
Yes. So the execution of load test using any tool for that matter, whether it be JMeter, BlazeMeter, or any other tool for that matter, we need to be very well aware that how much memory, the bandwidth, and the CPU this execution of test is likely to take, so that we can basically collect that information from our tool documentation that is very much available in case of JMeter or any other tool, or even cloud-based service that we can utilize. We can basically give them the details, the context, and the details of kind of test load test that we are trying to execute, whether it be a spike test, whether it be an endurance test, whether it be a breakpoint test, you know so we need to give properly know the requirement, understand the requirement, and then be able to get the kind of value calculated that to execute with, let's say, 50,000 user. We would need definite kind of bandwidth available, because on our machines and with very limited kind of a bandwidth, it won't be, it would be basically fruitless. So we want these kind of impediments would render our test execution to be futile, because we won't be able to execute or reach the peak of our desired value within a specific period of time, because there will be a underpower. In case of an underpowered machine, there will be a certain impact in terms of execution of these tests. So yes, definitely we should basically be aware and calculate based on our needs and the number of virtual user and how long the test is likely to continue, how much load it's likely to execute or increase or decrease in a period of time. So there are multiple, many factors to it that you can correlate and research and get a kind of a benchmark figure to reach and discuss with your IT infrastructure team like DevOps to properly have the infrastructure in place at which you can deploy your script and execute that script with all the kind of necessary conditions or requirements based on your business use case.
Thank you, Khurram. Do we
Yep.
have any more questions? If not, let's just wait a minute if anyone wants to type anything.
Yeah.
Okay, yeah. Out of all the tools you have mentioned, which of these can be integrated in the CI pipeline to maintain quality of our API?
In case of I mentioned Prometheus, we also have Grafana. These are very nice, kind of robust kind of applications which we can utilize for making sure that our, the entire testing, process is that, and the kind of monitoring that we are looking for is, is seamless. In terms of CI/CD, you can go with like Jenkins, create a pipeline for this and create your performance test with kind of conditions that you are looking for and make them part of the CI. Generally speaking, these kind of heavy load test, endurance test, stress test, or tests like that, they don't become part. They are not recommended to become part of CI because CI/CD, because we don't want them to be executed every time a new code merge request is generated. So we would like them to be, on scenario, on instances, on event based, where we are, let's say our application is ready to be rolled out and we want to test our application and API layer performance from every perspective that we just talked about, many other types that we talked about. So in that scenario, we would set our performance script with kind of conditions and our get our infrastructure ready to execute these load tests and make sure that we identify as many gaps or issues or errors that we can discover, insightful information that we can discover, to work with the team, the development team, with the infrastructure team, and everyone together to make sure that these issues and these gaps are addressed. So generally, that's not the practice, but we can basically use CI/CD tool like Jenkins or even GitLab or any other tools to make it, create a pipeline and make them part of it.
Okay. I'm just going to give it another minute if anyone has any more questions. Okay, so I think we don't have any more questions, so we can just wrap it up. Thank you so much, Khurram, for delivering this session, and to everyone for coming and being a great audience. We will be uploading the recording of this session on our YouTube channel in a few days, and we will also be sending you a survey link to hear your feedback on the session. So thank you, everyone.
Thank you, everyone. Thank you.
Yeah. Have a nice day. Bye.